Artificial Intelligence, History and Evolution. 1. Introduction to Artificial Intelligence. Artificial intelligence, AI, refers to the development of computer systems that can perform tasks typically requiring human intelligence. These include learning, reasoning, problem-solving, perception, and language understanding. 2. The origins, before 1950s. Mythology and philosophy. Concepts of intelligent machines existed in ancient myths, like Hephaestus's mechanical servants in Greek mythology. Mathematical foundations. George Boole, Boolean Logic, 1847. Alan Turing, Turing Machine, 1936, who later proposed the idea of machines simulating any human reasoning process. 3. Birth of AI, 1950s. Alan Turing, 1950. Published Computing Machinery and Intelligence introducing the Turing test to evaluate machine intelligence. Dartmouth Conference, 1956. Coined the term artificial intelligence, John McCarthy, Marvin Minsky, Nathaniel Rochester, Claude Shannon. This marks the formal founding of AI as a field. 4. The formative years, 1956 to 1970. Early programs. Logic Theorist, 1955, by Newell and Simon. ELIZA, 1966, an early natural language processing program by Joseph Weizenbaum. Optimism. Early AI systems were rule-based and showed promise in solving specific problems. Predictions were overly ambitious, machines matching human intelligence within a generation. 5. The first AI winter, 1974 to 1980. Causes. Limited computing power. Failure of AI to scale to complex real-world tasks. Funding cuts from DARPA and other institutions. 6. Expert Systems Era, 1980s. Rule-based AI. Rise of expert systems like Mycin, for medical diagnosis. Used if-then rules to simulate decision-making. Commercial use. AI was used in business applications like decision support. Downfall. High cost of maintenance. Led to second AI winter, late 1980s, early 1990s. 7. Machine Learning Renaissance, 1990s-2010s. Statistical AI. Shift from symbolic AI to data-driven approaches. Rise of machine learning, Bayesian networks, and support vector machines. Milestones. IBM's Deep Blue defeats world chess champion Garry Kasparov, 1997. Emergence of natural language processing, speech recognition, and computer vision technologies. 8. Deep Learning and Modern AI, 2010s present. Breakthroughs in deep learning. Use of artificial neural networks, especially deep neural networks. ImageNet, 2012, AlexNet's success in image recognition. Major events. Google DeepMind's AlphaGo defeats Go champion, 2016. Generative AI, rise of GPT models, ChatGPT, DALL-E, etc. Applications. Healthcare, autonomous vehicles, finance, virtual assistants, robotics, and creative industries. 9. The era of responsible and explainable AI. Ethical concerns. Bias, surveillance, job displacement, and decision transparency. Explainable AI, XAI. Focus on making AI decisions interpretable. Regulations and policy. Global discussions on responsible AI governance, e.g., EU AI Act, UNESCO AI Ethics Guidelines. Artificial Intelligence, Tools and Frameworks. 1. Introduction. Artificial intelligence, AI, development relies heavily on tools, libraries, and frameworks that facilitate model building, training, deployment, and scalability. These tools range from low-level programming environments to high-level abstraction layers, providing flexibility for researchers and developers. 2. Programming languages for AI. Python, most popular due to simplicity and rich ecosystem, TensorFlow, PyTorch, scikit-learn. R, used in statistical modeling and data analysis. Java, enterprise-level applications, used with libraries like Deep Learning 4J. Julia, emerging for high-performance numerical computing in AI. C++, performance-intensive AI applications like game engines or embedded systems. 3. Major AI frameworks. A. TensorFlow, by Google. Open-source deep learning framework. Offers Keras API for ease of use. TensorFlow Lite for mobile, TensorFlow Extended, TFX, for production. B. PyTorch, by Meta/Facebook. Dynamic computation graph. Easy debugging, popular in academia. TorchServe for deployment. C. Scikit-learn. For classical ML, classification, regression, clustering. Built on NumPy, SciPy, and Matplotlib. D. Keras. High-level API running on TensorFlow. User-friendly and fast prototyping. E. MXNet, by Apache. Scalable and supports multiple languages, Python, R, Scala, Julia. Backed by Amazon, used in AWS. FJAX, by Google. High-performance numerical computing. Automatic differentiation and GPU/TPU support. G. Hugging Face Transformers. NLP-focused library. Pre-trained models for BERT, GPT, T5, Roberta, etc. H. OpenCV. For computer vision tasks. Image processing, object detection, face recognition. 4. Tools for data preparation and visualization. Pandas, data manipulation. NumPy, numerical computation. Matplotlib/Seaborn/Plotly, data visualization. DVC, data version control dataset tracking. Label Studio/CVAT, data labeling for supervised learning. 5. Model deployment and monitoring tools. TensorFlow serving/TorchServe, serving trained models. ONNX, Open Neural Network Exchange interoperability between frameworks. MLflow, experiment tracking, model registry, deployment. Kubeflow, Kubernetes-based ML workflow orchestration. Seldon Core, scalable ML model deployment on Kubernetes. 6. AI cloud platforms. Google Cloud AI Platform. AWS SageMaker. Azure Machine Learning Studio. IBM Watson Studio. Features: AutoML, model training, hyperparameter tuning, monitoring, and deployment. 7. AutoML and no-code tools. Autosclern/TPOT/H2O.ai, automated machine learning pipelines. Google AutoML/Amazon SageMaker Autopilot, no-code AI development. Teachable Machine, Google's simple tool to train models with a GUI. 8. AI for Edge and Mobile. TensorFlow Lite. Core ML, Apple. ONNX Runtime for Mobile. NVIDIA Jetson Platform. 9. Generative AI tools. OpenAI GPT models, ChatGPT, Codex, DALL-E. Stable Diffusion/Midjourney/Runway ML. Image generation. Core contributors to AI. 1. Data. Foundation of AI. AI models learn patterns from large volumes of structured and unstructured data. Types: text, images, video, audio, sensor data. Data quality: accurate, clean, and labeled data improves model performance. 2. Algorithms. Machine learning, ML supervised, unsupervised, reinforcement learning. Deep learning, neural networks like CNNs, RNNs, transformers. Statistical methods, probability, regression, clustering. 3. Computing power. GPUs/TPUs, required for training deep learning models. Cloud infrastructure, scalable and flexible computing via AWS, Azure, GCP. Edge computing, running AI on devices like mobile phones and IoT sensors. 4. Programming languages and frameworks. Languages: Python, R, C++, Julia, Java. Frameworks: TensorFlow, PyTorch, Scikit-learn, Keras, MXNet. 5. Human expertise. Data scientists and ML engineers, design and build models. domain experts, provide insights and context for data and model evaluation. Ethicists and legal experts, ensure responsible AI development. 6. Hardware infrastructure. Storage systems, for massive datasets. High-performance CPUs/GPUs, for faster training and inference. IoT devices, for data collection in real-time environments. 7. Training and feedback loops. Model training, using labeled datasets. Feedback mechanisms, for improving accuracy over time, active learning, online learning. 8. Research and innovation. AI research labs, OpenAI, DeepMind, FAIR, MIT, Stanford AI Lab. Papers and preprints, AR14, NeurIPS, ICML, CVPR, AAAI conferences. 9. Policies and ethics. AI governance, rules and frameworks for responsible AI. Bias mitigation, ensuring fairness, transparency, and accountability. Regulations, GDPR, AI Act, EU, NIST guidelines. 10. Collaboration ecosystem. Open source communities, GitHub, Hugging Face, TensorFlow Hub. Academic industry partnerships, fuel applied research and real-world AI solutions. Competitions and benchmarks. Kaggle, ImageNet, GLUE, Superglue. Branches of AI. 1. Machine learning, ML. Focus, learning from data to make predictions or decisions. Subtypes. Supervised learning. Unsupervised learning. Reinforcement learning. 2. Deep learning. A subset of ML using artificial neural networks, especially useful for image recognition. Speech processing. Natural language tasks, e.g., GPT, BERT. 3. Natural language processing, NLP. Enables machines to understand, interpret, and respond in human language. Applications, chatbots, language translation, sentiment analysis. 4. Computer vision. Enables AI to interpret and process visual information, images and videos. Applications, facial recognition, object detection, medical imaging. 5. Robotics. Combines AI with mechanical systems for autonomous actions. Applications, industrial robots, autonomous vehicles, surgical robots. 6. Expert systems. Mimics human decision-making using rule-based systems. Uses, diagnosis systems, financial forecasting, troubleshooting. 7. Fuzzy logic. Deals with reasoning that is approximate rather than fixed and exact. Applications, smart appliances, decision systems. 8. Evolutionary computation. Uses algorithms inspired by natural evolution, e.g., genetic algorithms, to solve optimization problems. 9. Speech recognition. Converts spoken language into text. Used in voice assistants, transcription services, accessibility tools. 10. Planning and scheduling. Enables machines to plan sequences of actions to achieve goals. Useful in robotics, logistics, autonomous agents. Does artificial intelligence require coding? Does artificial intelligence require coding? Yes, artificial intelligence, AI, typically involves coding. In most AI development processes, programming is crucial for creating algorithms, models, and systems. Coding enables the AI to process data, make decisions, and learn from experiences. Some common programming languages used in AI include Python. It's the most popular language for AI due to its simplicity and rich ecosystem of libraries, e.g., TensorFlow, PyTorch, scikit-learn. R, often used in statistical analysis and machine learning. Java, known for scalability, it's used in large AI systems. C++, known for speed, it's used for performance-critical AI applications. However, for those who are not familiar with coding, there are no-code AI tools that allow users to build AI models with minimal or no programming knowledge. These tools are user-friendly and typically use visual interfaces to design workflows and automate tasks. Let's dive a bit into both coding-based and no-code AI solutions. Let's dive a bit into both coding-based and no-code AI solutions. 1. Coding-based AI. If you're interested in coding AI, here are a few core areas you'll need to focus on. Programming languages. As mentioned earlier, Python is the most widely used language in AI, mainly due to its simplicity and powerful libraries. If you want to build machine learning (ML) models, you'll work with libraries like TensorFlow/Keras for building deep learning models. PyTorch, another powerful deep learning library. Scikit-learn for general machine learning algorithms. Pandas and NumPy for data manipulation and numerical computations. Mathematics and statistics. A good understanding of linear algebra, calculus, and statistics is important for building and understanding AI models, especially for deep learning. Machine learning algorithms. You'll need to learn about supervised and unsupervised learning, reinforcement learning, neural networks, and more. Data preprocessing and model evaluation. You should know how to prepare data for AI models, cleaning, normalization, and how to evaluate your models for accuracy, precision, recall, and other metrics. If you're new to coding, I recommend starting with Python. There are plenty of tutorials available online, from introductory ones to more advanced machine learning projects. 2. No-code AI tools. Google AutoML, a Google tool that provides an easy way to train custom machine learning models without needing to write code. It automates much of the machine learning pipeline, from data processing to model training. Lobe.ai, a Microsoft-owned platform designed to allow anyone to build custom AI models with a simple interface. It's great for image classification and object detection. H2O.ai, an AI and machine learning platform that also supports no-code solutions, enabling users to build models with an intuitive interface. Beginner-level AI projects. Spam email classifier. Use NLP and ML to classify emails as spam or not. Movie recommendation system. Build a basic recommender using collaborative filtering. Handwritten digit recognition. Train a CNN model using the NIST dataset. AI chatbot for FAQs. Create a simple rule-based or NLP-based chatbot. Face detection app. Use OpenCV or HAR cascades for detecting human faces and images. Wrench intermediate AI projects. Sentiment analysis tool. Analyze tweets or reviews using NLP to classify sentiment. Object detection system. Use YOLO or SSD models to detect and classify objects and images. AI-based resume parser. Extract structured info, skills, education, experience from resumes using NLP. Stock price prediction. Use time series forecasting and LSTM to predict stock trends. AI virtual assistant. Combine speech-to-text, NLP, and task automation. Rocket advanced AI projects. Autonomous drone navigation. Build a drone that uses AI to detect obstacles and plan routes. AI for medical imaging. Train a CNN to detect anomalies in X-rays, MRIs, or CT scans. Deepfake detection. Create a model to detect manipulated images or videos using GANs or classifiers. Emotion recognition system. Use facial landmarks and CNNs to identify emotional states from facial expressions. AI-powered legal document analyzer. Automate legal clause extraction and risk analysis using NLP. Brain research-oriented ideas. Explainable AI, XAI, for healthcare diagnosis. AI-powered mental health chatbot. Ethical bias detector in ML models. Federated learning framework for IoT devices. Multi-agent reinforcement learning for smart cities.